Hi everyone, let's start with our new lesson, which is topic 6 that focus on the pollution control instruments. So in this chapter, let's assume that, or let's imagine we are the government. We are trying to reduce emission by, for instance, 50%. So today's topic will tell us how we want to do it or how we want to achieve our target. In United States, the Environmental Protection Agency, or we call it EPA, will be dealing with this issue. However, in Malaysia, we have the Departments of Environment under the Ministry of Environment and Water. They also will be dealing with this pollution control. Okay? How do we achieve a target? So in this topic, we will be focusing on the domestic pollution, not pollution that goes across the border. We will talk about the international pollution in the later chapter. Sometimes intervention is not necessary. If let's say we think that the private sector can solve it in a causation fashion, means that the market can do bargaining voluntarily, so they can achieve efficient solution. So there is no need for the government to intervene. Sometimes the optimal abatement is actually equals to zero. For instance, small amounts of salt in the river might be no problem. So efficiently, we shouldn't do anything to intervene. Okay? Sometimes the intervention cost might be huge. So in this case, it doesn't pass your cost-benefit analysis. So you shouldn't do anything because by doing nothing, it is the efficient solution. Okay, numerous instruments are actually available with their pros and cons. So you have to compare between these two. And different circumstances require different instruments. Okay, for your information, there is no single instrument that work best for all types of pollution. Sometimes different types of pollution may need different instruments to handle it or to tackle it. Okay? Option for the government to reduce pollution. The first one is suasions or persuasion. So basically, government can persuade people to stop throwing rubbish, or perhaps giving educations or campaign to its citizens to create awareness. Government can also ask the company to disclose their information on the pollution activity so that the company will be very careful when they want to discharge their pollution. Or perhaps government can also give prize to the cleanest place in the town. Okay, the next option to reduce pollution is that government can use regulation. So when we are saying about regulation, we are referring to commands and control. Government can say to companies that you must pollute at this level, or perhaps you must use this kind of technology when you want to reduce your pollution. Or government can also say you must limit your output at this level. So normally, government will give its command and then observe whether the command is efficient or not efficient. The next one has a different color, which is market-based approaches. So I will explain these approaches later on because it has a few branches, or we have a few discussion on these approaches. The last one is public provisions of funding. In this case, government use their own money, perhaps to fund the cleanup operations, or they use their money to fund for R&D to reduce emission. Okay, under market-based approaches, you have price-based. So what is it? It is just putting a price on the pollution. Okay, for instance, you impose tax to reduce the pollution. Or perhaps you want to give subsidy. If let's say the company purchase abatement technology, okay, so definitely abatement technology is very expensive. So government will give subsidy to reduce the cost of purchasing. Okay, next one is quantity based. So quantity based is actually very similar to price based, but in this case it wanted to restrict the quantity of pollution. So both of these methods are actually inspired by the works of Pigot when they want to put price on the pollution. Okay? So the last one is market facilitation. In this case, government can do something to actually allow or facilitate the market to work better. For instance, the government can actually clarify the property right, providing information to the company and to the public, reduce transaction costs and so on. In this case, government is just like adding the causation approaches. So normally in the real world, okay, the government will use mixed approach. Okay, so many policy approaches are actually hybrid. Okay, so for instance, you are using education or campaign. You campaign your people to actually turn off the light. At the same time, you also apply the regulation. So you are imposing that to the public that they should purchase the light that has an energy efficiency criteria. You can also combine many other approaches as well. Okay. What are the criteria to assess policy to reduce pollution? There are a bunch of criteria to assess our policy. The first one is cost effectiveness. This is something that is loved by many economists. It means that does the instruments achieve the target at the least cost way? Second, you can also look at it in terms of long-term effects. So does the influence of the instruments can increase in effects over time? So you want the effects of the instruments is increasing over time. Dynamic efficiency. So we want an instruments which encourage the company to invest in ways to reduce emissions over time in a very low cost manner. Okay, so you can also look at it in terms of ancillary benefits. So does our instruments allow for double dividends or more benefits when you want to achieve it? Okay, you can also look at it in terms of equity, whether it has an effects on the distributions of incomes or wealth. And you can also look at it in terms of dependability. Okay, so basically to what extent that the instrument can be relied upon to achieve our target. If let's say there is a shock in the economy, can it sustain over time? Okay, so you can also look at it in terms of other criteria. Okay, there are also many other criteria on top of what I have mentioned here. So if you look at these blue words, basically you can also consider about political stability criterions, enforceability, and so on. Okay. Addressing pollution is often best done through market-based instrument because it can establish a price to get the incentive right. So economists often recommend market-based instruments for a bunch of reasons. The first one is that if the price of pollution is higher, we will demand less of the pollution. Second, market can actually deliver emission reduction in the least cost way. So basically this is the remarkable characteristics of market-based instrument. Next, everyone can be brought into the emission reduction efforts. For instance, if there is a broad price on one type of pollutants, it gives an incentive to a company to reduce the pollution. It can also give an incentive for people to reduce consumptions of products that have a lot of pollution in them, and also give incentive for the research to reduce the pollution. If there is a price on the pollution, you can make money out of it and encourage people to work together. Okay, next, the price signal can actually provide an ongoing incentive to reduce pollution, or we call it dynamic efficiency. Next, so basically government doesn't need to involve in making decisions to reduce the pollution, and government can leave it to the markets to reduce the pollution in the best way. Okay, the last one, government can raise revenue out of it. So for example, an emission tax can raise some revenue, which can be used for some purposes, for instance, providing public goods, or it can also be used to reduce other taxes. Okay, for your information, many taxes can actually distort the market system, which can lead to deadweight loss. Okay. Sometimes, market-based instruments are not always the answer. In some cases, the government doesn't need to set up any types of emission tax or emission trading schemes. If, let's say, the cohesion solution may be preferable. For instance, in this case, the private market can find their own solution. In some cases, outright bans could be suitable. For instance, when we talk about releasing mercury into the stream, or perhaps when we talk about nuclear waste. So in this case, we just have to use command and control, and the outright ban will definitely result positive infinity. In certain cases, control may be suitable. For instance, when we talk about farmer, we don't want them to use too much of pesticides. So we just have to let them know about it, especially when we have some threshold that we don't want them to cross. And we just have to set the rule to make it clearer. So it is easy then to have the price-based approach. In certain cases, pricing mechanism may not be possible because it is too costly, especially when we talk about non-point source of pollution. So in this case, we don't know. It is hard for us to identify which source of pollution. If let's say we are talking about so many firms that are polluting a river. So it is very costly to impose the price on these types of pollution because we have to monitor the company. So it is not suitable for us to use the market-based instrument. Cost efficiency. Why economists love so much about cost efficiency? So cost-effective instruments can actually save a lot of resources and save our money for other purposes, and at the same time can also achieve our targets. So what is the principle to achieve cost efficiency? So for the least cost abatement, the requirement is that the marginal cost of abatement should equals for all abated. So mathematically, this is the requirement. So this requirement is definitely necessary to achieve cost efficiency. However, for the overall efficiency, we also need to achieve the efficient level of pollution when we set the price should equals to the mu. Let's illustrate the least cost abatement via emission price on a graph. So this is the marginal abatement curve for firm 1. So if you look at this curve, what can you say about it? Initially, to reduce the emission, it is quite cheap. But when the firm has more and more pollution, the cost of reducing the pollution is higher. And this is the marginal abatement cost function for firm 2. So you can see here that firm 2 has a lower marginal abatement cost function. So now, who do you think is better at abating? So the answer is firm 2. Who do you think will be doing more abating? The answer is still firm 2 because firm 2 can abate at a lower cost. Let's imagine now the government introduced the price per units of emission, which is shown in a green line. So how much of these two firms are going to abate? So firm 1 will definitely compare the green line and the red line. So firm 1 will keep abating until this point, okay, which is Z1, right? So after this point, firm 1 will not abating and will just pay the tax because the cost of abating is actually more expensive than the cost of paying the tax. How about firm 2? Firm 2 will abate here. Okay, so here clearly we can see that firm 2 abate more than firm 1. So basically, government doesn't need to know the MAC curve for each of the firms and be confident that they can achieve the least cost abatement. So in this case, command and control is likely to be more costly because it is hard for the government to guess that the firm 1 should abate at Z1 while firm 2 should abate at Z2. Okay? And basically government need more information to find it out. So information means more cost. Okay? Okay, given the previous discussion, prove that graphically definitely command and control will result in higher costs to both of the firms. For instance, if let's say government take the average abatements emission for both, so you will arrive at Z3. So we will discuss this answer during the class time. Math of the least cost abatement. So let's define some letter. Z is actually our abatement or reduction in pollution. C is the cost of abatement. I is the abatement source. Or let's assume that it is like a bunch of firms. So in other words, it can also be the source of emission. So our goal here is to minimize the cost of reducing pollution by some quantity. Okay, so we want to minimize the total cost of abatement across the whole economy and subject to the big Z. So we also have our constraint here, which is target total abatement. And this Z equals to some quantity. So another way of saying the constraint is that abatement across all end sources is in summations of the big Z. So in this case, we have to use Lagrangian function. So the first thing is that we have to write our objective and then plus with the co-state variable, which is our lambda, and in the bracket, this is our constraint in a rearranging form. So let's do our first order condition. So partial derivatives of L with respect to Z. So where is our Z? So you can see Z here. That's why you have partial C over partial Z. And another Z is here. So you have to minus with lambda and set it equals to 0. And let's just take the shortcut. Let's assume our second order condition. Okay, for a minimum, we have this upward sloping marginal cost of abatement for each firm. So in this case, we will have our convex cost function. Okay, now let's rearrange our first order condition. Okay, so we will write it this way, partial C over partial Z and equals to lambda for all I. So in other words, we will be saying that our marginal abatement cost should be equated across all firms or all source of emission. So we will call it in principle equi-marginal principle. Okay, so it says that at the margin, the efficient solution is actually equals across all source of firm. Okay, let's analyze one policy. So tax equals to tax per units. Each firm will be minimizing their cost with respect to Z. So their cost is actually includes the cost of abatement together with TZ. So if let's say they abate their emission, they are able to avoid paying tax for every units of their abatement. So let's do first order condition. D cost over dz equals to C prime Z minus T and set equal to 0. And second order condition, D square cost over dz square, we will get C prime Z. And let's assume the marginal abatement cost is positive and we will get the minimum overall cost. Okay, now let's rearrange the first order condition. We will get C prime Z equals to T. So in other words, this equation is saying that a per unit tax work in achieving the least cost abatement. So we can say that higher tax, so when our T is higher, definitely it will lead to more abatement. So the left hand side should also be higher. This is the examples of cash for clunkers. In June 2010, Australian Prime Minister announced a policy to purchase and scrap vehicles of more than 15 years age. So people definitely must purchase a fairly efficient new vehicles to receive the payment. So the goals of the government is basically to reduce the emission. So the government proposed $100 million per year to solve or to achieve these targets. So now my question is the policy consistent with the least cost abatement? Why or why not exactly? So we will discuss this question during the class time. The answer is it is not the least cost abatement because the marginal abatement costs are not equated across different cars or across different sources of emission. Second, we will have a rebound effects. So when the government asks people to purchase an efficient car, people will drive more on the road because they believe that their cars is efficient, so they will have low emission. However, when more people drive their car on the road, it will contribute to more emission. The next one, some people will buy a new car anyway, so basically there is no impacts on the emission reduction, so it will be a waste of money. While some people who drive old cars will scrap their cars and will perhaps not buy a new one. Artificially, it can actually increase the car turnover rates and may increase the emission. So for your information, for energy efficiency, the optimal car turnover is around 19 years. It is not around 15 years. So the remaining life is about 4 years. Command and control operates by imposing mandatory obligations or restrictions on the firm's behavior. So command and control can actually perform well if, let's say, the monitoring systems is available and the harsh penalty can be imposed if, let's say, the firms violate some rules or regulation. Command and control instrument. Basically, government can intervene in all stages of production process. Government can restrict the input used by the firms. For instance, government are saying you shouldn't use this kind of input in producing your products. So government can also intervene in the production technique. For instance, government specify what kinds of abatement technology that the firm can use. And government can also restrict the quantity of good produced. For instance, government can put quota of how much the good can be produced. And government can also control the emissions output, means that you can just emit this kind of pollution. Okay, government can also set the ambient pollution requirement in that area. And last, government can also specify that this area, this zone, is not suitable for the company to operate their operation. So government can also intervene in that way. However, it is not economically practical if the government want to apply the command and control in the production process. First, with respect to the non-transferable emission quota, basically, it is unlikely to be the least cost because the governments have an imperfect information on the firm's marginal abatement cost, and the cost of information is actually huge if the governments want to find it out. Dynamic incentive to have zero pollution among the firm is also lacking. Okay, if let's say the governments want to control the technology used by the firms or input put in the production, basically the cost is expensive and you will not achieve the least cost manner. So does one size of technology fit for all firms? Okay, do you think that the small firm and the large firm can use the same technology? It cannot fit all types of firms, definitely. So basically, it is not the technology or inputs that we care about. Basically, we care about the externality. We care about the pollution, right? So in general, it is better for the government to control the pollution rather than to control other things like input, technology used by the firms and other things, so as not to reduce a firm's flexibility. So basically, we have to use direct targeting. What do we target? We target to reduce pollution. So we just leave the firms to do whatever they could to reduce their pollution. So basically, we allow for the firms flexibility. Okay? Markets-based instruments work by altering prices and therefore create incentive to voluntarily changes in the behavior of the firms. So the examples of market-based instruments are like emission charges or tax or emission abatement subsidies. We can also have cap and trade, hybrids of the above, deposit refund scheme, non-compliance fees, performance bonds, and liability payments. So in this chapter, we will be focusing on the first one and the second one. Okay? How to set the emission tax? So step 1, we have to decide a pollution target. So we have to set economically efficient level of pollution from a net benefits maximization calculation. Step 2, we have to set emission tax equals to per unit price required to reach the target. So if the target is the efficient one, so this price should equals to the mu. So based on the Pigovian principle, pollution should be priced at marginal external cost and at the efficient pollution level. This is just the benefits before policy from the governments or marginal benefits before tax. So the marginal benefits is declining and this is the marginal damage from emissions. So the firms will pollute at M star where the marginal benefits equals to marginal damage that corresponds to the mu star, or we call it shadow price. So the idea of Pigovian taxation is to introduce that price as the real price called emission charge. So now let's clear off that damage curve. So let's imagine the company is being taxed for polluting. If they are being taxed, the benefits of polluting is actually less now. So the marginal benefits curve will shift downwards by the size or by the gaps of the tax. So the company will keep polluting until the marginal benefits equals to zero, which is at M star. So that's the idea of emission tax. So basically the government just put the tax in place, so the company will automatically have an incentive to reduce their pollution from M hat to M star, which is the efficient level. Okay, so basically government can collect the tax revenue at this area. So basically after the tax, the company will pollute at socially and economically efficient level. In other words, the tax can actually internalize the externality as if the pollution cost entered into their private cost function. And a similar looking graph could also be drawn for a firms or for an industry. Let's do the graph in a different way. So the x-axis here is the emission abatement. Previously, it is emissions. So the marginal abatement cost is increasing, exactly the same as the previous marginal benefits of emitting, because the cost of not emitting is actually the benefits of emitting. So this is emissions equal to zero. Previously, it is m hat, which is the maximum level of emissions. So let's imagine government imposed tax equals to mu star. So we will abate at z star. Okay, so the tax revenue collected is this box, the same size as the box in the previous slide, which is equals to the per unit tax, which is the mu star, multiplied by from emissions equals to zero, which is here, until the z star, which is here. So basically this area are the emissions that we are not abating. So therefore we have to pay the tax, while this area is the emission that we are abating. So we don't have to pay tax on it. So basically we can use both graph or approaches. And these approaches tell us that if we put tax in place, so basically the firms will have an incentive to reduce their pollution. Emission tax in the context of markets for good X. So this is our supply curve, which is equal to the marginal private cost. And this is our demand curves, which is equal to the marginal social benefits. So when the supply and the demand curve intersect with each other, we will have the private equilibriums. So P1 here is actually the equilibrium price. So let's assume that when we want to produce our good X, we are actually creating marginal external cost. So when we take into account this marginal external cost, we will have marginal social cost. So socially, the efficient point is actually at x2 instead of x1. Okay, so now the efficient tax rate is actually the pink line here. Okay, which is the difference between marginal private cost and the marginal social cost. So there are two things that you can observe from this diagram. The first one is that the efficient tax rate, which is this line, is actually equals to the marginal external cost, which is this line, at the efficient level or at the x2. Second, if we apply a tax per units of this pink T, okay, then the total revenue will be given by this rectangular. Okay, in this case, basically the government earn more money than the damage caused by the externality, because if you look at this marginal external cost line, which is the red line, it is actually lower than the tax revenue collected by the government. So is it fair? We will discuss about it later in the class times. Okay, so basically this is a famous graph, but in reality normally we want to tax the externality, not the goods. Okay, why do you think an emission tax works? First, the tax will eliminate the difference between private and socially efficient prices. Therefore, it will internalize the externality. So basically, the decision will reflect all costs, not just the private cost of the firms. And the firm will actually reduce the pollution until their marginal abatement cost equals to the tax rates. So each firm will also do this. So definitely their marginal abatement cost will be equated across all firms. So definitely we will get the least cost abatement. What does the government need to know if they want to set an emission tax? So to achieve efficient emission targets, government need to know the aggregate damage function as well as the aggregate abatement cost function. Another words of saying the abatement cost function is the benefits of emitting. Then, once we have done that, we can set the per unit tax equals to mu and we will achieve the efficient level of pollution. So basically, government does not need to know each firm's marginal abatement cost function. So therefore, there is a big informational advantage over the commands and control instruments. So basically, information is very costly because the firms have an incentive to mislead about their true marginal abatement cost function. Okay, another point here is that if you want to achieve the least cost abatement of some quantity, basically the government doesn't need to know anything about it. So government just have to put a per unit tax in place. So basically the firm will achieve the least cost abatement. If there is an emission price take place, the firm will have an incentive to reduce pollutions over time. So we call it dynamic incentive to reduce pollutions. So let's assume that this is our marginal abatement cost function for firm 1. Let's imagine we have emission price per units. So the firm will definitely choose to abate at Z1. Well, the firm might think of doing some research or work out ways to reduce cost of emissions. Okay, basically we can say that the firm has an incentive to innovate to reduce their marginal abatement cost functions. So let's say they are able to reduce their MSC1 to MSC2. How much money are they saving? So if their MSC is lower, definitely they will abate more. So there are two ways of looking at the saving. Okay, so the first one is that previously the firms will have a higher MSC, but now they will have a lower MSC, right? So basically this orange area is actually the saving that they get from having a lower MSC. So the next one is that this is the second saving that the firm will get. So previously the firms will abate at Z1. So above this Z1 point, definitely the firm has to pay the tax. But now at the lower MSC, this area is actually the saving that they get from avoiding paying tax. Okay, so these two areas, the orange and the purple area, are actually the total saving that they could get from reducing their MSC1 to MSC2. So the point here is that with the emission price, there is the potential benefits from doing research and developments. Okay. Let's assume that instead of imposing tax, the government wants to give subsidy. Which one do you think is preferable by the firms? Interestingly, emission tax and emission abatement subsidy will have an identical effects in terms of pollution outcomes, at least in the short runs. However, the abatement subsidy are actually better for the firm's profit because they will get additional income from their abatement. But it is worse for the government's budget because they have to pay for it. And if you use the abatement subsidy, we will miss out the chance for having a double dividends. In the long run, the subsidy may mean that the industry is getting larger. It means that our supply curve will shift to the right. And in this case, we will have a higher pollution because giving subsidy will encourage more firms to join the markets. Okay? Abatement subsidy. This is the marginal benefits of emission before tax or before subsidy. This is the marginal damage of emission. Okay, we know that if we leave it to the firms, they will love to pollute up to M hat. However, the efficient point is actually at M star. If let's say the government wants to give abatement subsidy, the marginal benefits curve is actually lower, because if we emit, we cannot get the subsidy from reducing our emissions. So we expect the marginal benefits curve is falling. Previously we did this graph. It is falling by the distance t, where t is the per unit tax rate, while for the abatement subsidy, it falls by the distance s, where s is the per unit subsidy rate. Okay, with subsidy, basically the firms can get S1 and S2. However, because the firm has to reduce from M hat to M star, so S2 is the loss of benefits to firm. So this is the resource loss or resource cost used by the firms to reduce their emission. And the net gains to the firm is just S1. So if let's say we want to use tax instead of subsidy, so basically the governments can collect tax revenue of S3, 4, 5 and 6. So because the governments or because the firms has to reduce their emissions from M hat to M star, so S2 is the loss of benefits to the firms. So in this case, the net gains to the government is S3, 4, 5, 6 as well as S2. There are two important points here. So the first one is that if let's say we use subsidy, the firms will get the net gains of S1. But if we use the tax system, the firm will have a net loss of S3, 4, 5, 6 and S2. Second, basically under tax, the firms will pay more than the value of their damage cost. Okay, so if you look at the marginal damage curve, basically the firms cause the damage of S4 and S6. However, the firm have to pay the area of S3 as well as S5. That's why the firms don't like to have the tax system. Okay. Information requirements if you want to use subsidy approach. Disadvantage of abatement subsidy is that the government is required to know what is the M hat. This means that there is a larger information required. It means that it will involve higher costs. When emissions are changing year to year, guessing the counterfactuals or the baseline, or we can say business as usual emission level, is a huge problem. So firms will have the incentive to mislead about what emission will be without the abatement subsidy in order for them to get a larger subsidy. So this will give a trouble to the government.